heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists brave some of the worst weather on the planet to improve our understanding of our warming world.
Hello, everyone, and welcome to the Mount Washington Observatory virtual classroom. My name is Alex Branton, and I am a weather observer and education specialist here at the observatory. And I'd like to thank those of you who have been attending this program throughout the school year. I guess you guys are familiar with the way that this works. If you're new to the program, the way that this works is that we upload a recorded video every week on a variety of different topics, and that is going to be followed by a live Q&A session by the presenter the following week, where you'll have the opportunity to ask any questions about the material covered during the virtual classroom or any questions about the observatory in general. Today, we're going to be talking about North American climates and the climate on top of Mount Washington specifically. So let's get started. First, let's kind of talk about the difference between weather and climate. These are two very different things, although sometimes they might get mixed up. They are different. Weather is the current or near-term state of the atmosphere, whereas climate is a typical weather for a location based on averaging the weather conditions, usually over a 30-year period. So, in other words, climate is what you expect, but weather is what you get. So what factors can determine an area's climate? There's a variety of different things, but we're just going to talk about a few of them. Elevation, annual sunlight, topography, and proximity to large bodies of water. These are all different things that can affect the climate in very different ways. So let's talk a little bit about how elevation might affect the climate. So first off, temperatures cool with height. So the higher you go in the atmosphere, or the higher you go on a mountain, the cooler your temperatures are going to be, therefore the cooler your climate is going to be. You also have increased wind, rain, and snow at these elevations, which leads to a wetter climate, whereas if you were down below in a valley. You also have to deal with inversion layers, which is when the temperature actually warms with height. Usually this happens in the morning, and it happens more so when we have a stable atmosphere, and this can affect the temperatures that you can see at your location. Annual sunlight is also a factor when we're considering climate, and this is influenced by the distance from the equator or your latitude on the Earth. So the closer you are to the equator, the warmer your temperatures are going to be, because the more sunlight you're going to get at a more direct angle. The farther away you are from the equator, the cooler your climate is going to be, because you get less sunlight and it's at a much lower angle in the sky. So it also changes on an annual basis, depending mostly in the mid-latitudes how much sunlight that you get. And again, you have less heat when you're further away from the equator. Those locations near the equator are going to be warmer. Those locations near the poles are going to be a lot cooler. Topography is also a really big factor when determining climate. One of the main reasons why is the orographic effect of mountains. So mountains have a tendency to make or take rain away. So in this map over here in Washington State, we have the Cascade Range. As you can see, the vegetation is much greener on this side than it is over here, where we have more desert-like conditions. And that's because the rain kind of gets caught on this side of the mountains, and all the precipitation falls here. Whereas on this side of the mountains, you don't really get as much precipitation, so you have more of those desert-like conditions. Valleys can also act as frost pockets, and you can see those again in this map over here in these white areas. And that's whenever low-lying areas such as valleys develop cold pools overnight. So cold air sinks down from the mountains at nighttime. Again, that's kind of like what your inversion layers are. But when you have a frost pocket in the valley, your air temperature cools to where ice can form, and that can affect your climate as well. Proximity to large bodies of water also has an effect on climate, mostly because it has a much higher heat capacity than the Earth. So whenever you're near a large body of water, you don't have as much diurnal variation in air temperature, or annual variation in air temperature, because the water is acting to kind of regulate what your air temperature feels like on the land. You can also get the land and sea breezes that develop. The sea breeze develops during the midday, whenever the earth is heating much faster than the ocean surface, and therefore you get winds coming offshore towards the land. We can also get the land breeze at night, which is whenever the earth cools much faster than the ocean next to it, or the large body of water next to it. And then you get the opposite effect. You get a wind blowing from the land towards the sea. Another effect that large bodies of water can have are lake effect snow, like we're seeing in the Great Lakes. Warmer air or cooler air goes over the top of the warmer lakes and it creates a bunch of snow and large accumulations. And it can be in very, very specific locations as well. So there's one main way that we kind of describe or that we classify climate zones, and these are called the Köppen climate classifications. The first way that we can kind of designate climate zones are by these letters here, and I'll show you on a map on the next slide, but let's just go over what these letters mean first. The A designation means tropical or a hot and humid climate. B means dry, which means very little precipitation. These are going to be like your desert areas. C, your temperate climate zones. These are warm and humid summers with mild winters. Continental are designated by the letter D, and these are warm and cool summers with very cold winters. Next, we have E, which designates the polar climate zones, and these are your extremely cold places on Earth. And then we have the highlands, which is kind of an all-encompassing term to describe mountainous areas with climate that differs from the surrounding area. So that just means you have a much different climate at the top of the mountain than you do everywhere else around it. So this is what these climate classifications look like on a map in North America, or more specifically in the United States. As you can see, there's not that much variation, especially down here in the Southeast. Once we get out west, there's a little bit more variation, but more or less we're mostly in that temperate climate zone. But we can classify climate zones even further using the Köppen climate designations. And we can add second and third letters. So the second letter adds divisions based on precipitation patterns, and the third letter adds divisions based on temperature patterns. So we can further get wet year-round, dry summer seasons, dry winter seasons, and monsoons. And these are designated by the letters F, S, and W, and M. So for our temperature divisions, we have hot summers, warm summers, cool summers, or very cold winters, and these are designated by the letters A, B, C, and D. So let's take a look at a map of what the United States looks like now when we add these further designations. So as you can see, there's a lot more variability once we add once we add more climate variables into the classification. And I'll go ahead and full screen real quick so you can see it a little bit closer. So we have all these the three-letter designations up here at the top. There's a lot going on, but as you can see in New England, we're mostly in that DFB range, which means we have snow, we are fully humid, and we have warm summers. But let's talk a little bit about what the climate zones of Mount Washington look like, because we know that that the weather in Mount Washington is a lot different on a normal basis, but so is the climate. So this is another map of the three-letter designations of the Köppen climate zones. And Mount Washington is this little speck over here, and that gets the subarctic designation, whereas the rest of New England gets either the warm summer humid continental designation or the hot summer humid continental designation. So we're subarctic up here on the top of Mount Washington. And that's because mountains are complex environments that can feature, or Mount Washington, when we are going up from the valley to the top of Mount Washington, you can experience 3 different climate zones because up at the top we are subarctic. But when you're going from the bottom up to the top, we experience much different climate zones, and that's because mountains are very complex environments. Topography and elevation are the major factors that impact climate on a mountain. So the topography of Mount Washington is really rugged, and that's really what separates us up here from the rest of New England. And we are at a much higher elevation than the valleys below us. And again, Mount Washington exhibits at least 3 distinct climate zones, with their own unique characteristics. So let's take a look at what those climate zones look like if you were to go from the bottom of Mount Washington to the top of Mount Washington. So if we start here at the bottom, we have our humid continental climate zone. And then as we go up a little bit further, we're in the subarctic climate zone. Up even further would be the Alpine tundra. And it's really, really easy to see that in this image because we have so much snow and ice up here near the top. And then it's a little bit greener down here because these trees do not lose their leaves in the fall. But down here, we have our deciduous forests that do lose their leaves in the humid continental climate zone. So let's take a little bit deeper look into these different climate zones. So in the humid continental climate zone, it is humid with severe winters and no dry season and a warm summer. This is what it looks like if you were to go from North Conway to the base of Mount Washington. And it consists of northern hardwood forest. Some trees that you might see if you were to go travel around the valley here near Mount Washington are the sugar maple, the American beech, and the yellow birch. Some animals that we have down at the base of Mount Washington are black bear, moose, deer, and bobcats. So there's a lot of variability. There's some good biodiversity down near the base of Mount Washington. So as we go up further, closer to the top of the summit, so this is about the middle section between the valley and the summit of Mount Washington. We are in the subarctic climate zone where we have boreal forests. So it's found around 2,500 feet, and this is designated by severe winters, no dry seasons, and cool summers. And other places that this type of climate zone is found is northern Canada and parts of Alaska. Some trees that you might see in this climate zone are balsam fir, red spruce, paper birch, and mountain ash. And some animals that you might see are lynx, snowshoe hare, and red squirrel. So again, some good biodiversity here in this climate zone. But we'll see as we go up a little bit further, there's a lot less that can survive in that kind of climate. So now we're at the top of Mount Washington, and we are in the Alpine tundra climate zone. And this happens once you pass tree line. Or right around tree line. It's found around 3,500 feet to 4,400 feet. This climate zone has no true summer and severe winters. Other locations that this climate zone is found is Alaska, northern Canada, and the Arctic Circle. And then we like to say that once you get past tree line, you are now in the Alpine zone environment. The Alpine environment can be very fragile. So if you do come visit Mount Washington, just keep that in mind when you're walking around the trails. The Alpine zone is very fragile, and it would be really helpful to the environment if you stay on trails. So some plants that you might see up in this climate zone are Krumholtz trees, which means crooked wood. And this is basically an all-encompassing term for any tree that's found around tree line whose growth is stunted by the wind and the elevation. So some Krumholtz trees that we see up here are balsam fir and black spruce. And we also get some mountain cranberry plants as well. The other plants that live up in the Alpine zone are generally really, really small, flowery plants in the summertime. We can't really get any other plants except for grasses and flowers that grow up here at the top of Mount Washington. Some animals that we do see up here on occasion are pine martens, mice, and ravens. Outside of these, there's not really a whole lot else that can survive up in the Alpine zone, or really want to try to survive up here in the Alpine tundra climate zone. There's just not a whole lot of things for them to eat. It's really cold. The conditions are really harsh up here. So that wraps up all the information that I have about climate zones in North America and the climate of Mount Washington. So let's go over some big takeaways before I leave you with all this information real quick. Some big takeaways. Climate refers to the typical weather of a region over a minimum of at least 30 years. So you average all the conditions that you've recorded over 30 years of data, and this is your climate zone. Again, this is different from weather because weather is the day-to-day weather that you would experience. Climate is the weather that you experience over 30 years at least. The North American continent has a vast array of regional climates that are influenced by elevation, sunlight, topography, and proximity to water. There are many, many other variables that can affect a location's climate, but these are just the biggest ones that we can go over today. Climates can be further subdivided based on additional local factors related to precipitation and temperature throughout the year. And Mount Washington is a complex environment with at least 3 distinct climate zones that you experience when you go up from the base to the top of Mount Washington. So climate is a really fun subject. If you'd like to learn more, I'd be happy to see you in our live Q&A session for the climates of North America and the climates of Mount Washington. You can register for that live Q&A session on Zoom. In that way you will have the opportunity to ask questions in real time. We do also broadcast it on Facebook Live, but if you join on Facebook Live, we won't get to your questions till after the fact. But if you would like to submit questions ahead of time, that way I can have more time to answer them more thoroughly. You can email them at education@mountwashington.org, or you can go ahead and submit those questions when you're registering through the Zoom. Thank you guys so much for watching this video about the climates of North America and the climates of Mount Washington, and I hope to see you at our live Q&A session. Thank you.